Good afternoon, everyone, and welcome to Tech Talk Tuesday. Again, here at Treadwell. If you're joining us for the first time, welcome. And if you've joined us before, welcome back. We hold these sessions every second Tuesday, every second week, typically on a Tuesday, I should say. Do a quick 15-minute session where we go through some commonly asked questions, standards reviews, previous projects, variety of different things. So firstly, any feedback's welcome, good, bad, or ugly. If it was worthwhile, we'd love to know. If it wasn't worthwhile, we'd like to know that too. And secondly, any suggestions you've got for either queries that you'd like to see us address in the way that we addressed 3 queries today, or any other queries you've got, feel free to flick them through. We'll have an email address at the end, and we'll have a quick Q&A session at the end as well for any quick questions that come up, either related to today's content or any other FRP things. So firstly, we're going to start off with we're going to cover 3 common questions today. We've done one of these sessions before, and obviously open to do them again, or open to do further sessions. Feel free to send your questions through. We'd love to do them. So first up, FRP is more expensive. This is something we often get asked or noted as far as the cost of FRP compared to some other materials. So there's a few factors here. Firstly, we'll talk about some costs of ownership and installation, so on. And then secondly, we'll just do the next page. We'll have a quick comparison between FRP and other, shall I call them, traditional materials like steel, stainless, and so on, and how we typically see FRP stack up. So firstly, on the installation aspect. So client feedback tells us that often FRPs cost less to install, and that's brought about by a couple of factors. Firstly is the reduced weight, so less manpower to install, but also smaller cranes and those sort of things. We've had feedback from clients who've done some projects in tight access where rather than having to bring in a large crane, if they're going to do a steel structure and they had to do some ground stabilization works to allow that to happen, they could simply use a franner and not need to do any ground stabilization when they went to an FRP structure. So that's a significant cost saving. Another thing is on difficult access sites. FRP can be brought in and stick built on site, or pre-assembled and helicoptered in, or brought in on a crane truck with a hire or something along those lines. So opportunities for cost saving there. The other aspect is in electrical environments, FRP doesn't need earthing or bonding. So that's another scope of works. It's not necessary. The other aspect is the life cycle cost. So, for example, steel structure we mentioned here, which you need to have a blast and paint maintenance regime. FRP doesn't need that, so you're saving over your life cycle. Just as a brief cost comparison, this is just from some feedback we get from our clients. So start off with floor grading. Feedback we get is FRP is often very competitive with hot dip gale steel. Something to note, occasionally FRP will not be able to do as large a span. In some instances it can. We have some products that will span equally or better than your traditional steel grading products like an A325 or something along those lines mesh. However, in some instances you might have a slightly reduced span. So that's something to bear in mind, but the cost of the grading is typically very competitive, sometimes lower, sometimes a little bit higher, but typically pretty well in the ballpark. Now, FRP handrail, we make a handrail system. We've done other webinars on that. If anyone would like to see some more on that, feel free to have a look on our website or YouTube channel. We've done some other webinars on the handrail, but we offer a full FRP handrail system. Now, market feedback is FRP is competitive with blast and paint steel. So any steel with a blast and paint spec, FRP is typically equal or lower in cost and better than stainless, similar to aluminium. Question from Martin. Thanks for asking this, Martin. This is supply only, so that's what we're discussing today is around supply only. So hence the comment that sometimes FRP is a little more expensive as regards to supply only price, but from an installation perspective, there's cost savings to be had. So this cost comparison is specifically just material supply only. On structures, so that's FRP platforms, cooling towers, access, those sort of things. Once again, blast and paint mild steel is about where FRP lands, lower than stainless, similar to aluminium. On the cable ladder and cable tray, this is a common one. Competitive with aluminium products, won't be competitive with just a galvanized product, unfortunately, but competitive with aluminium and lower than stainless. And then boardwalks, by way of an example, feedback we get is they're competitive with a good quality hardwood. However, they will be higher than a softwood, but typically you'd see a lot better lifespan than a softwood product, and often better than a hardwood as well. Another question, all FRP is the same. This is something else we get. I use by way of an example, our floor mesh products, yellow mesh, green mesh, they must be the same. They probably come from the same factory. Now, unfortunately, that's not the case, and green or yellow or grey or colours don't mean anything anymore in the industry. Back when FRP was new, there was things you could determine from colour. Typically, yellow was the highest chemical resistance product. Green was more splash and spill type, or limited exposure, and then there was some more neutrals like your greys and charcoals and so on that were more for your public access type projects, so no chemical exposure. However, that no longer really applies from the perspective that we've seen, where some clients require chemical resistance but have a specific colour in mind, whether it be to match something on site. We've done blues, reds, greens, yellows, or they want one of the standard colours like a charcoal or a dark grey. They need a chemical resistant product. So unfortunately, appearance is not something that can be relied on, especially currently in the current market with the way it's evolved, to determine what's in a product. So our recommendation is that you have certain performance requirements around your product. Now, that could be by way of a specification, that could be by way of asking a supplier what their product meets as far as testing and compliance, and we'll have a bit of a look at that in the subsequent slides as far as what those compliance aspects might look like. But just by way of example, they've had a Treadwell product on the top and an alternative product on the bottom. Now, the alternative product relies on a paint coating for its colour and its UV stability, and you can see installed very similar time, 2018, and the photo taken in 2023 for both. So not a very long, about 5 years, not a very long lifespan really, and you can see that the alternative product that relies on the coating has firstly has quite a poor appearance due to the paint coating delaminating, but secondly, that is the paint coating is providing a UV stability in that instance as well. And you can see the coating is not there anymore. That stability is not going to be provided, and you'll see premature degradation of that product. The other thing is proper resin selection. Now, we've done a webinar on this, so I won't go into it in great detail today. We've also got a white paper on our website if you'd like to do a bit of reading on around resins, different resin types, and why we need to specify some resins in some applications and other resins in other applications. But briefly, resin selection is like a coating spec for a steel structure. If you've got a structure on a rooftop of a building, hot dip galvanized finish will give you a good durable structure. If you put that same structure in a sewage pump station or a wet well or a mine processing site or somewhere like that, that galvanized structure is not going to have a very good lifespan at all. So resin selection is the same idea. Different resins are better in higher temperatures, lower temperatures. Different resin types will withstand different chemical exposures, acids and caustics better than others. And different resin types also have differences around their fire performance as well. So we'd like to engage in discussion to get something that's fit for purpose for your project. But on performance criteria, we offer some specs. I won't read this one out to you, but it is available if anyone wants to drop us an email. Happy to work with you to get the right spec for your project. But some points for comparison, very briefly, and couple of points that we often include or suggest to clients include in the specification. Excuse me. Color pigmentation versus coating. So that's how your color is obtained, whether it's a sprayed or applied coating, whether it's integrated into the product. Fire performance, there's a variety of fire testing. ASTM E84 is a very common one that's been used on FRP for a long time. So more recently, we've seen demand for some other tests. AS1530 Part 3 is another one. And the National Construction Code refers to ISO 9239. So once again, happy to help with the applicable testing. For example, 1530 Part 3 is a vertically oriented product. So if you're using it as a cladding or a balustrade, that would be especially relevant. ISO 9239, which the National Construction Code references, is horizontal, so that's more applicable if you're doing flooring or walkway mesh or something like that. However, some certifiers will want to see both or use one or another for a means of comparison. Happy to provide that testing and help you work through what is going to give you, excuse me, I'm having some voice troubles here, what's going to give you the best durability and the right performance. Slip testing is another common query and something to point out. AS4586 has a couple of different test methods. The wet pendulum method and the oil incline method are the two most common references, and we have both of those to put in the specification. AS4020 is for potable water usage, so that's products in potable water storage, so ladders, diver platforms, those sort of things. Need to see that testing to use a product in potable water storage. And a big one, especially in this region, Australia and New Zealand, UV stability. There's a few tests to check this. A lot of tests just measure fading. Now, fading is a bit of an indication, obviously, of what's happening with the product, if it's being aged or deteriorated. But more importantly, we'd encourage applying the accelerated aging to a test specimen, and then excuse me, and then having some mechanical testing done after the aging process has been completed, and that'll tell us if there's any level of deterioration in the structural properties of the material. So not just shading and appearance, which is often tested, which is important around paints and those sort of things, but with a structural product, we'd like to see a bit more than that. Also mechanical properties in this table here, once again, happy to share it. Some standard properties for our products, which is determined through testing. Especially if you're using structural materials, it's important to state what properties you've used, because FRP is not all equal. Different manufacturing methods, different manufacturing companies will have different mechanical properties. So if you're using an imported product made in, say, the USA, might see different properties to if you're using a product that's made in Asia somewhere, or if there's a variety of different properties. So important to note what you've based your calculations on. And then, nearly finished. Sorry, we're getting out of time as well. Resin selection and surface finish. So we've mentioned paint coatings, we've mentioned chemical resistance and those sort of things. Important to consider these as well. Just bear with me. I'll just have a drink of water to start to lose my voice for some reason. And sorry, everyone. Hopefully that's a bit better. And nearly to the end, this is the last question. FRP can't be cut on site. Now, I had this one recently, and I'm not quite sure. I'm not quite sure where this has come from. Please excuse the voice. And this is not the case. FRP can be easily cut on. Sorry, but this is quite embarrassing with the voice. FRP can be easily cut on site using standard hand tools. We've done a session on this previously as well. but typically circular saws, grinders, and so with diamond blades or tungsten carbide drill bits. And then the most important thing is the finishing. So there's a couple of processes which are recommended. Firstly is deburring. So that's really for visual reasons, give you a nice clean finished appearance. Should be done with sandpaper or a deburring tool, which is like a small abrasive bit for holes and to deburr holes and edges rapidly, or sandpaper. And then resealing. Now, resealing is probably the most important aspect. And there's two reasons that one would need to recommend to reseal. Firstly is a visual perspective. We recommend internal color pigments. When the product's cut, you'll see some lightening of the color. So by simply resealing with the resin treatment, you'll restore that original color, so it'll gives a nice depth and appearance back. But secondly, FRP can be a little bit like the end grain of timber, in the sense that moisture can track through it if it's the cut edge is left untreated. So this just ensures that we don't see that moisture ingress, which gives us the best durability. So it's not going to immediately fail, for example, if you don't, but best practice for maximum durability, you should reseal cut edges. Excuse me. That's the end of the session. I'm sorry about the voice. We might keep Q&A pretty brief because I'm not sure how long I'm going to be able to talk for. But feel free to drop us an email, hello@treadwellgroup.com.au, or give us a call, 1-800-246-800 for Australia, 0800-244-600 for New Zealand. As I mentioned earlier, happy to have any feedback, good, bad, or ugly. And please, a lot of our topics we cover come from suggestions by those who join our session. So please feel free to make a note of that. Another question here from Martin, which I'll try and answer with my voice hold up. Any respiratory hazards? The short answer is no. We can offer you an MSDS if you're working with a product which goes into more detail, but the short answer is no, FRP is not a hazardous dust, and WorkSafe South Australia and various other bodies support that. However, obviously breathing dust in general is not advisable from a health perspective, so we'd suggest that you use a P2 dust mask while you're cutting the product, or you wet cut to manage the dust. But as far as the dust itself being hazardous, like say asbestos or something, no, that's not the case. I hope that makes sense. That's the end of the session. Stay on for half a minute or so if there's any more questions. I'll try and answer them if the voice will work. Otherwise, feel free to send them through, hello@treadwellgroup.com.au. And as I said, any ideas on future topics or feedback that would be gladly received. And we look forward to seeing you in 2 weeks' time for another session. Thank you very much.